I gave you these 3 problems to try at the end of the last video. Let's just remember how this is defined. The function f times g, if I'm evaluating that at 3, that just means I'm going to evaluate both functions at 3, so f of 3 and g of 3, and then multiply the results. Okay. So if I look at f of 3, I'm just plugging 3 in here, so that's going to be 1 over 3 plus 2. G of 3, that's this function, so I'm plugging in 3 for both x's, so that's going to be 3 squared plus 1 over 2 plus 3 times 3. So let's simplify each of these, so that's going to be 1/5 times 3 squared is 9 plus 1 is 10 over 3 times 3 is 9 plus 2 is 11. So I'm just multiplying 1/5 times 10/11. I can cancel the 5, it goes into 10 twice, so I'm going to get 2/11. All right, let's take a look at h divided by g of 9. Same basic principle here. What we're looking at is plugging 9 into both functions and then doing the arithmetic. Then we'll divide the results. So h of 9, I'm just plugging 9 in for x in the formula for h, so that's going to be the square root of 9 minus 5, over g of 9. Now that's going to put a fraction on the bottom here, so I'm going to get 9 squared plus 1 over 2 plus 3 times 9. So let's simplify each part. This is going to be the square root of 9 minus 5 is 4. Square root of 4 is just 2. I'm dividing by this fraction. 9 squared is 81, plus 1 would be 82, over 3 times 9 is 27, plus 2 is 29. Now, if I'm dividing by a fraction, I'm going to just flip and multiply. So this is the same as 2, which I might choose to write as a fraction, 2 over 1, times the reciprocal, which would be 29 over 82. Looks like I can cancel a factor of 2, and so we'll get 29 over 41. Excellent. So let's try our last one. That was f plus g of 3. So again, the rule is I'm just going to take 3, plug it into both functions, and then do the arithmetic, then add the results. So that will be f of 3 plus g of 3. F of 3 is 1 over 3 plus 2. G of 3 is 3 squared plus 1 over 2 plus 3 times 3. So that's 1/5 plus 3 squared is 9 plus 1 is 10 over 9 plus 2 is 11. So I've got two fractions with different denominators. I do want to fully simplify my answer. So in order to add fractions, I need a common denominator. So it looks like we're going to use 55. So I'll multiply this fraction by 1 in the form of 11/11, and this fraction by 1 in the form of 5/5. That's going to give me 11/55 plus 50/55. And of course, 55 plus 55 gives me 55. So once I have a common denominator, that doesn't change. And then I've got 11 plus 50, that's going to be 61 of them. And it looks like that fraction does not reduce, so that would be my final answer for that third problem.